All right, section 2.5.
Yay.
Similar figures. Similar figures have the same shape, but not necessarily the same size. So they're different, Deegan, from congruent figures. Congruent figures have the same shape and the same size. Now they could have been slid around or reflected or rotated. Similar figures have the same shape, but not the same size. So anytime that you've ever taken an image before off of your phone and enlarged it or shrunk it down, then you've created a similar figure. Anytime you've played with a, I don't know, a Matchbox set, or what are they called? The little people, the baby toys?
Little people.
You've played with similar figures. Now I will admit it's not quite similar because the little people that I see now have the big hole cut out in their feet, so you can put them like on a tractor, on an airplane or something. Most people don't have a big giant hole missing from their foot, but similar. A Barbie doll, for example, maybe, you know, or sorry, Christian, a Ken doll, right? Yeah, so those would be similar. Same shape, but obviously different size. Now, when we think of that, a lot of times we think of like shrinking something down, but it can also be enlarging something. So for example, if you've looked in your science textbook and you've seen a picture of a cell, well, a cell's really not that big. The cell is much, much, much smaller. You can't actually see it with the visible eye, so they've enlarged it. Something that would have been reduced, obviously, would be like a solar system, shrunk down so you can see the rotational orbits of all 8 planets, right? So 8. It used to be 9. I still kind of think it's 9. I'm not sure. I'm not sure Pluto's not a planet.
Pluto's a planet.
All right. So here's what makes. I've heard it's a dwarf planet, but whatever. They'll probably change their mind about Neptune next. I don't know. You know. 2 figures are similar when corresponding angles are congruent. Now, what's that word congruent mean again?
The same.
The same, yeah, same shape, same size, equal measure. That's actually what the word congruent means, equal measure. So in order for them to keep the same shape, you can't change any of the angle measurements because you will create a different shape if you do that. What you can change is the side lengths. And so, but you have to change them a certain way, otherwise you'll change the angles, which we cannot do. So the corresponding sides have to be proportional. So last year you would have solved proportions. You may not have talked a whole lot about similar figures, but it's the same idea. The corresponding angles have to be congruent. That's what this means. That's the congruent symbol. Remember the equal sign, the squiggly line above it. The corresponding angles have to be congruent, and the corresponding side lengths have to be proportional, which means if I place one over the other, make it a fraction, all the fractions have to have that same ratio. Now, we talked about congruence statements. Similarity statements are the exact same. So if I say triangle ABC is similar to triangle 2, then I have to use the same order in which I used for the previous one. So notice I went from ABC. A was the 3-ticked angle, to B, which had 1 tick, to C that had 2. And so I have to do the same thing. So I'd have to go triangle D, E, and then F. It's not the only way I can do it, but it's probably the most common. And then the word or the phrase similar to can be replaced with this symbol, which is just the squiggly. So like the congruent symbol, except without the equal sign here, it just has the similarity squiggly there. So that means is similar to. You could also have said triangle CAB is similar to triangle FDE. There's more than one way you could write a similarity statement. Which rectangle is similar to rectangle A? Now, they're all the same general shape, but rectangles do have different shapes. Like I can have rectangles that look like squares, and I can have rectangles that look like tall pillars, right, where they're skinny and tall. I can have, so they're still rectangles, but they're not the same shape. They don't have those same characteristics. So in order for me to check, I need to check two things. I need to check that the corresponding angles are congruent. I need to check that the corresponding sides are proportional. So what are all the angle measures of rectangles going to be, Owen? Yeah, so regardless of which angles I call congruent ones, because they're all 90 degrees, this is always going to check out for rectangles. So B and C both have the same angle measurements as rectangle A. But one of them is different as far as the corresponding sides. So the corresponding sides, we went from 3 to 6. What rectangle keeps that same ratio of the length being twice as long as the width, Lucy? Rectangle C. So rectangle C has to be the one that's similar, not B. They're both rectangles. I get that. But it has to have corresponding sides that are proportional. Here's how you can double check. So when it says proportional, you're like, all you did is check that the length was twice as long. Why is that called being proportional? Because I would say width to length of rectangle A has to be equal to width and length of rectangle C. And since both those fractions are 1/2, this is accurate. Also, you would have learned last year that when you cross multiply, if two fractions are proportional, the cross products will be the same. So 3 times 4 has to equal 6 times 2. They both do. If I try setting that up for the rectangle that we know is incorrect, not only does that look wrong, because it is, 3, 6 is not the same as 2, 6, but if I use cross products, I get 18 and 12, and those aren't the same. So in a proportion, the cross products are going to be equal. So one of the ways you can check to see if they're proportional is just cross multiply and see if you get the same answer for both cross products. Rectangle D is being added to the group now. No picture, just a description. It's 3 units long and 1 unit wide. So it has a ratio of, well, actually, I put width on top for every single rectangle up here. So I should probably put the width on top here, keep my ratios consistent. Which rectangle has a ratio of 1 to 3, Xander?
B.
Yeah, rectangle B, because it has a ratio of actually 2 to 6, which reduces to 1 to 3. And so my cross products are both 6 for that one. So I know that rectangle D is going to look exactly like rectangle B, but would rectangle D be bigger or smaller? Is rectangle D bigger or smaller, Lizzie? Why do you say bigger? B is bigger. Okay, so rectangle D is smaller. Okay, why do you think rectangle, you said B is bigger? Why do you think rectangle B is bigger? How can you tell?
Because the length is 6 for that one.
Yeah. Exactly. The length of rectangle B is 6, but the length of rectangle D is 3. So they must have reduced it down a little bit. Still kept that same shape though. All right. So instead of asking you if these triangles are similar, I'm going to reverse it now. I'm telling you that they are. You have to find the missing side. So we would normally have to check 2 things to see if they're similar. But if I'm telling you that they're similar, that means the angles are definitely, the corresponding angles are definitely equal. That does not mean all the angles are equal to each other. That only happens on an equilateral triangle. It just means the corresponding angles are equal. But I just need to see if the sides are proportional. So there's a couple different ways you could set up your proportion. The technical way of setting it up would be to say that 6 corresponds to 9. So 8 has to correspond to X. It's not the only way you could set it up. Some people would set it up as 6 is to 8. So that side of the triangle versus this side of the triangle. So if I do 6 is to 8, you would then have to do 9 is to X. And really there's more than one way to set it up as long as you're being consistent with how you do it. What you'll notice is that regardless of how you decide to set it up, X and 6 are always diagonal for each other. So everyone's going to get the same answer. You'll get 6x equals 72 when you cross multiply the 9 and the 8 together. And then 72 divided by 6 is what? Brady? 12. So x equals 12. And because it's a geometry problem, yes, we do need to label, and it's meters. Just meters for this one. So more than one way to set up your answer. Martin, how would you set up example B?
6 over x equals 9 over 6.
Okay. 6 over x. So he went with the bottom portion of the small triangle to the vertical-ish portion of the small triangle to the bottom-ish portion of the big triangle to the vertical-ish portion of the big triangle. And that gives you that proportion. It's one way you could do it. That works. Martin, what do you get for x times 9?
9x.
Good. And what do you get for 6 times 6?
36.
And what does x equal then?
4.
X equals 4. Yeah, I'm running out of room, but divide by 9 and you get 4. Good. 4 what? 4
4.
feet. Let's slide this over a little bit. Okay, good. I was going to say trapezoid, but these are not trapezoids. That bottom side is not parallel to the top side. So just a quadrilateral. Let's see. Sky, how would you set up a proportion for C?
14 over x.
Okay, that works. And then go ahead and cross multiply it, Sky. I'll do x times 7. You do 14 times 12. Tell me what you get. 168. Go ahead and divide it by 7. 24. And what are we measuring in? 24 centimeters. Good. So a lot of proportions on today's work paper, which means I want to see your proportions. I want you to write your proportion down, and then I want you to cross multiply it and then label your answer when you're done. Okay, final one here. Seth, tell me what proportion you would use for example D. Give me one, start with one side. You gonna start with 8, 4, X, or 6? Start with 4. Okay. So one way you could set it up is you could say the bottom side of the small triangle corresponds to the bottom side of the larger triangle. What's the bottom side of the larger triangle?
6.
6. So you could say 4 is to 6 as now, since you started at the small triangle, we got to go back to it. We got to be consistent. What's the vertical side of the small triangle?
8.
8. Okay. And then what's the vertical side of the big triangle? X. And that's why you can set your proportion. It's not the only way. In fact, a lot of people I've been calling on, I've noticed have been doing something like 8 is to 4 as X is to 6. And that works. That works. It's just not lining up the corresponding sides. It's not a big deal. You don't have to do that. But again, this is the technical way of doing it. Seth, what do you get when you cross multiply the 6 and the 8 together?
48.
Good. So we got 4x equals 48. And tell me what x is going to equal. You may need a calculator. X equals 12. 12 what? 12 centimeters. Good. All right. Moving on to the next part. It's interesting. An artist draws a replica of a painting that is on the Berlin Wall. Now, what do you guys know about the Berlin Wall? What do you know, Owen? That would be correct. So you had the Soviet side of Germany, and then you had the, what did they call the other side? Yeah, it was East and West Germany, right? I'm trying to think what the Soviet side, yeah. So East and West Germany, yeah, split them. And actually this wall, I don't know if you know a little bit about it or not, it practically went up overnight. So some people were actually separated from their families, just depending on what portion of town they were in, because this goes through the capital of Germany, which is Berlin. And so some people were actually separated. And then they had this like no man's land area between, and they would literally shoot people that tried to cross the without crossing at the gate. And they didn't really let anybody cross anyways. So it really did divide Germany. And I believe it went down, you might have to Google confirm this. I think it was like 1991 is when it actually was torn down. And there's a famous clip of, I think it was Ronald Reagan says, "Mr. Gorbachev, tear that wall down." And I think that's when it happened. So, but now a lot of it, there's even the parts that remain, I believe, just a lot of obviously graffiti and stuff like that on it. So yeah, Carson. Yeah, the barbed wire, just about anything, and there's guard towers everywhere. Yeah, so you really just didn't cross. You were separated. Yeah, yeah. There's a movie with Tom Hanks that came out probably 15 years ago. Something about spy something. I have to look up the name, but it's this time period in Germany. And it just shows you how severe this wall, like when it came up, it was devastating to a lot of families. All right, anyways, an artist draws a replica of the painting that is on the Berlin Wall. The painting includes a red trapezoid. I don't know where the red trapezoid is on this painting. Are you guys seeing it?
Yeah, it's not really trapezoid, it's square, but because the angle is taken from it's the first one.
That could be. That could be. There's a lot of interesting graffiti on this wall. But anyways, we have it right here. It wants to know what H would have to be. Okay, so it's basically just what we were doing before. Deegan, what's a proportion that you would write without Maddox's help for this problem? Okay, good job. Now, we're using decimals here, probably going to want our calculator. Deegan, what do you get when you cross multiply the, I'll do the 15 times H part. You do the 3.75 times 12. 45. Oh, using Sky as a calculator?
Yeah.
Instead of having your own out? You were, okay. Well, you probably do this in your head. How many times is 15 going to 45 then? 3 times. And what were we measuring in? 3 inches. Yeah, so on the artist drawing, which is smaller than the actual wall, but similar, their H on the trapezoid would be just 3 inches instead of 12. All right, so it's homework time. I've got, let's see, 2 homework problems left for us to do in our notes that I thought we'd talk about. These are ones that you could easily guess and check on and learn 0 from. So I want to make sure we actually talk about them. Number 14. When you get to number 14, you can just copy this over from your notes. It says, are the following figures always, sometimes, or never similar? 2 triangles. Can 2 triangles be similar? Yes. Okay, so it's either sometimes or always. What do you think, Sky? Maybe. Well, there wasn't a maybe option. So what would maybe represent? Always, sometimes, or never? Sometimes, yeah. The answer would be sometimes. I can give you an example of 2 triangles that are both triangles. They're not similar because the corresponding angles are not equal or congruent. So just because they're triangles doesn't make them similar, but they could be. If you drew it instead like that, then I could have 2 right triangles that would be similar. Could be if I had the sides correct. But any 2 triangles don't have to be similar. What about 2 squares? What do you think, Maddox? Always. Correct. They always have to have 90-degree angles. And because they're squares, the corresponding sides are always going to be equal. Or not, sorry, equal, proportional. If you had a 4x4 square and a 9x9 square, 4/9 equals 4/9. Doesn't matter what 2 sides you're looking at. Yeah, so 2 squares are always, you can't draw a square that doesn't look similar to somebody else's square. Unless you just can't draw a square, which in case you use notability, draw your right angles. What about 2 rectangles? What do you think, Xander?
Always.
Not always. Sometimes. Here's a counter example. This is a rectangle. You might call it a square, but it is a rectangle. This is a rectangle. They're not similar, even though the angle measures are 90, right? We know that. They don't have to be similar. Same with the triangles, right? They could be if you drew them correctly, but you don't have to draw a rectangle that's similar to another one. And when it says a square and a triangle, you would say those are always, sometimes, or never similar, Dawson? Never, not even the same shape, not even the same number of sides. So that can't work. Number 16, all the angle measures in this sign are 90 degrees. So it's a rectangle. You increase each length by 20%. What is the new sign? Is the new sign similar to the original? If you increase each side length by 20%, are you multiplying each side by the same factor? Yeah. In fact, what would you be multiplying it by? If you're increasing it by 20%, be careful. Xander? Jacoby? 1.2. If you just multiply by 0.2, wouldn't that shrink it down? It'd be 20%. So the fact that this enlarges it means that you don't want to, so timesing by 1 or 100% keeps it the same. Then increasing it 20% actually makes it 120%. Yeah, so 1.2. Yeah, that would make it similar. And as long as you're timesing the length and the width by 1.2, it will still be similar. If you just do the length, that's going to take your rectangle that looks like this and make it look like this. And so now we have a slightly longer rectangle, not similar. So you have to do it to both length and width. So this would, yes, this would increase. Or sorry, this would make it similar. Part B, you increase each side length by 6 inches. Is that going to make it similar? Someone other than Xander can have a shot at this one. Maddox, what do you think? Why? That's correct. When you're dealing with proportions, you're never adding or subtracting, right? You're always multiplying or dividing. You're either cross multiplying, dividing, you never add. Here's an example of that. Let's just say, and I don't know if this is accurate, but let's just say this is 10 and this is 7. Who knows? So the ratio right now would be 10 to 7, length to width. If I add 6 to each side, that would make it 16 by 13. And so here's an easy way to check. Is the ratio 16 to 13 the same as 10 to 7? 130. What's 7 times 16? Is it 130? Bet you it's not. I'll wait. What is it, Deegan? You think it's 112?
Yeah.
Deegan, the human calculator,
Good job.
112. Well, there's a way you could do it in your head, right? If you're Deegan, you could do 7 times 10, that's 70, and then 7 times 6, 42, and add those together to get 112, or you could just use a calculator that you all should have had out on your desk anyways. The answer is no, they're not similar. You can't add to the side lengths and make it similar. You can multiply by a factor, but you can't add a number or subtract and make them similar. So the answer to this one is, we're done.